Previously, we have already talked about the features of the step response in our underdamped second order system. I have a few interesting things talking about this step response feature. Okay, what you see here is an S-plane. So normally in our S-plane, you will be able to draw the poles of your second order system, let's say. In this case, let's consider an underdamped second order system. So if you have an underdamped second order system, like what we discussed before, we will have a complex conjugate pair of poles. Now, if you look at this drawing, this is an S-plane. And what you see in here, there are two vertical dash red line here. So what does these vertical lines mean? Vertical lines mean the location of the poles in your underdamped second order system, which will give the same settling time. So if you look at the equation of this settling time, if you look at this, your settling time, if we take the 2% criterion settling time, your settling times is equal to 4 divided by zeta omega n. It's inverse to the zeta omega n. Now let's take a look on the poles expression. Zeta omega n basically is the real part of your complex conjugate pair of pole, right? And sometimes zeta omega n, we call it as sigma here. So basically your settling time is inversely proportional to the real part of your poles. Your settling time only depends on the real part of the poles. And the horizontal axis in your S-plane is the axis that will tell you the real part of your poles, right? So what do I want to say here? If you have two or more underdamped second order system, but the poles of these systems are lying at the same vertical line, all of your underdamped second order system will have the same settling time. Okay, so let's say if you have two underdamped second order system, the first one has pole in here, I draw it with a blue color there, and your second underdamped second order system, the poles are in here. Let's say these two second order system have different set of poles, but all of the poles have the same real part, right? So the real part are the same for these two system. Then these two system will have the same settling time. Okay, so again, vertical line will tell us the system with the same settling time. Now, the next one that I want to share with you is horizontal line. If you refer to the formula of the peak time, okay, so this is the formula of the peak time. Peak time is inversely proportional to the omega d. What is omega d? Omega d is the imaginary part of the poles of an underdamped second order system. So what does it mean? This horizontal line will tell us the system with same peak time. Okay, so same like before, if we have two underdamped second order system, and then let's say the first system has pole, complex conjugate pair of pole at these two locations, right? And then the second system, it's also an underdamped second order system, the poles are at this location, if you're comparing these two pairs of poles, these two have the same imaginary part. The imaginary part is the same. That means the peak time will be the same. Okay, so again, horizontal line will tell us a system with the same peak time. The third thing is this line, this diagonal line. So if you have again an underdamped second order system that share the same diagonal line, what I mean by diagonal line here is the line that is from the poles to the origin of the S-plane. If you have second order system, again second order system underdamped, but they share the same diagonal line, you will have this system with the same maximum overshoot. Okay, so again, if there are two underdamped second order system, but the first system has a pole at this location, I draw it 2 here because it must be a complex conjugate pair of poles. And then the second system, the poles are in here, let's say. Okay, these two systems should have the same maximum overshoot. Okay, so in summary, this is what I just mentioned in the previous slide. If you refer to the first drawing here, if you have three underdamped second order system, the first system, the poles are in here. The second system, the poles are these. And the third system, the poles are at this number 3. So these three underdamped second order system will have the same settling time, right? If you have a system with the same settling times, so the envelope of the step response will be the same because this will refer to the same settling time. On the other hand, if you have two underdamped second order system, the first system has poles at this location, and the second one, the poles are at the location indicated by number 2 there. These two systems will have the same peak time, right? If you look at this drawing, the peak time for both of them are at the same time. The last one, if you have 3 systems again, but the poles of these 3 systems are at the same diagonal line, the overshoot of the responses of these 3 systems, all of them will be the same, right? Okay, that's all for the unique property of settling time, peak time, and maximum overshoot.